So my name is Luke Sawczak, and I teach at Toronto District Christian High School. I'm in my 4th year of teaching, so I do not have a long track record. I apologize. I did do some TAing of comp-sci at U of T as well. And this is my attempt to capture a bit of a philosophy of science for AI, and I'll do my best. But I must say that it's obviously still a fledgling kind of thought process, and it does not have a lot of refined conclusions, and hopefully there'll be some chance for discussion as well. But I'll do my best. So this is actually based on an article that I published in Queen's Quarterly in last year. And I tried to bring together a few philosophers who I'd been reading and scientists I'd been reading. At the time, I did not know that Richard Feynman had all this misogyny stuff, so I try not to quote him this time. But that was brought to my attention. And you can feel free to go and read that article. I will use it here, but I'll also move past it because obviously a lot of things have happened in the last year. And yeah. So first, a little just thought experiment to talk amongst yourselves. I saw this article in The Atlantic a couple months ago, and it has this quote: "What if teachers use ChatGPT to instantly personalize lesson plans for each student in their class?" And I instantly questioned that, and I wonder if you were to talk amongst yourselves for a second, what problems might you see with this, if any?
First of all, like, unless you build relationships.
Yeah, sure. Well, you can share after talking for a second, but yes.
There's also the fact that it's not perfect. You have to read it. Like, you can put in your ideas in your lessons, but then you have to go through and sit through. What do you think? Very much right. No, yeah. It's not a good thing to do. And
meanwhile, Grant, I've got Dan Zingaro saying that he's modifying his approach. His next book is how to vet ChatGPT output when you're programming tests.
that being said, those are all the negatives. Yeah.
Okay, any thoughts to share initially? I'll save my own answer for later, but yeah.
Okay, we know there's pros and cons. So as a pro, it's a starting point. It's getting something started, and which sometimes can be the hardest part and the heaviest lift. But then recognizing when you're trying to personalize something, you're personalizing it on biased data, misinformation, hallucinations, whatever you want to talk about. So we have to bring our personal, like our judgment as educators to whatever it is that we create on there.
Mm-hmm.
And you have to have a relationship with the student. You can't expect a machine to understand the student.
Right.
That's why we're teachers.
Indeed, yeah. Any other thoughts to add? That was very valuable. Yeah.
I don't think there is a mistake.
Okay.
I think we should try that. It's not going to work. But why it doesn't work, I think, is going to be a very important explanation.
Well, and one might even say that this being phrased as a question, what if, is basically, as you say, opening a door, trying something. Like, there's not even a conclusion to state there, so maybe there's no problem with asking what if. Any other thoughts? Yeah.
If you try to personalize it, it might, it's like with algorithms, right? It may skew the output data, and there could be some sort of translation loss, if you will, between the different students.
Right. Yep.
So I've worked as an online tutor. It's all text-based chat back and forth. Superficially, it looks very much like an interactive chat. To the point where I've had a student ask me, "Are you an AI?" The really interesting thing was they asked, like, "Oh, what state are you in?" I was like, "Oh, I'm actually in Canada. I'm in Nova Scotia," and that's what convinced them. But that kind of tutoring, which is a student comes to you with a question, and you ask questions back and forth, and you figure it out. The questions that they come to you with most of them are very similar. A lot of factoring as well, like polynomials and stuff. That kind of thing ChatGPT. So, maybe what we're thinking here is that teaching is so much about being together in a physical space with someone, and all the body language and all the emotional stuff there, but at least in some context, students are learning just by typing back and forth, and that's something that ChatGPT can do. Because I mean, it wouldn't be perfect, but me as a tutor, I'm also not perfect. I've made plenty of mistakes. So, yeah.
Cool. Yes.
Well, teachers using it to personalize would be one thing, but in the scenario you just talked about, if the students were talking back and forth with ChatGPT, it disadvantages the students who have a hard time with text.
Yeah, interesting. I think that when we'll talk about modalities a little bit, modalities of teaching throughout. So these are good initial thoughts. Like I said, I'll save my own thoughts on this for towards the end, but yeah. So an outline of what I'll talk about. First, some simple tools, then some concepts that we're covering and not covering, and then 3 or 4 philosophical steps here in my thing: art and artifice, probability and parasitism, getting the A, humanity and humility, and next. And by the way, I would have started at 0, but there's no way to represent 0 in Roman numerals, so that's unfortunate. But yeah. Yeah, so first, this is actually, just to be frank, this is just because I find these things cool. This is actually not related to AI, but it's just to give a little bit of a contrast with some things. So one of the things that I love to do with my free time is to make random little simple tools. Some of them are useful in the classroom and some are not. I'll show you a couple of them. One is this cake cutter. So I realized that I'm really bad at cutting cakes properly. Especially in pizzas and so forth, especially if they involve a number of slices that is not an even number or is more than 5. So I have this little thing where you can get your labels and your arrows. It'll show you the cuts that you should make in your cake or pie or pizza, whatever it is. And you can just modify it to an arbitrary number. And as you can see, for even numbers of cuts, you only need like half the labels, but for the other ones, you should actually cut to the center, then cut from there. So this really helped me. But I quickly discovered when making this that actually the most fun part of it is when you get to arbitrary numbers of slices, you can create cool effects with your cake cutting to the point of creating a little black hole, perhaps. And so I found that this kind of maximizes, like this is not enough to feed anyone, of course, but it's maximizes depending on your screen at 999. And then I realized, why don't I just add some, like, because this is the most fun part of this this little simulator, why don't I make it possible to change the color of your cake? So you can make artistic designs here. And you can change the color of the cuts, and you can turn the pan on or off, and all that. And it quickly got divorced from the concept of the actual useful thing. But that I thought was, as I wrote in the Curtin article, as if you read that, the idea here was that it's a simple tool that is enjoyable by simple humans. And it doesn't actually take a lot of depth to appreciate that. Some of that we'll skip. You can always go through them later if you look at the slideshow. But here's a binary teacher. So I found that my students needed a lot of help understanding binary. And by the way, these were made at different times in my career, so some of them are less sophisticated than others. But for example, I show them the idea of bits. I teach them that bits are, all they are is a value that can be on or off. Then I graduate from there to representing on as 1 and off as 0. Then we talk about the place value of the columns, and we can start to multiply these, and we can represent that as binary. And then I started having them talk about the decimal values and adding up the columns there. So then this tool I've used for a few, and by the way, this is just a little bonus, so that if you get nothing out of my philosophy here, you can always walk away with some tools to add to your class. But yeah, that's binary. A couple more. RGB is not as impressive. Not that that's impressive, but anyway. Math Boggle. My little brother, he tutors math, and he asked for a way to generate random equations. So we brainstormed this idea of Boggle, which is with letters, of course, but this is with math equations. So it shakes and it makes this little sound, and you can, like the letters in Boggle, you can randomize your equations. You can pick a target. You can also rotate the board, and it makes a little shuffle sound. I really love the connection to the real world, the idea that you have the little shuff as if you were turning it. And there's all these settings. And this, by the way, was the most fun thing to create. The idea that you can change the proportions of different kinds of operations, and the sliders move along with that. You could change the range of the numbers that you're dealing with for younger or older students who are capable of doing more. You can also create a bias towards a particular part of that range. And this was the most fun thing. You can choose to favor prime numbers or not to make factorization easier or harder. And just the process of thinking to myself, what does it mean to favor a prime? Because he said, I want more prime numbers. And I said, what does that mean to mathematically to favor a prime? And 1 or 2 more. He also came up with this idea, the grid game. It's a very simple game. I'm sure there's variations of it elsewhere. I tell students, get rid of that corner dot, make it all one color. And then they go and they struggle for a little while. And eventually they realize that if you click the 4 opposite corners, then you normalize the color. And after some experimentation, they realize that A, this process is reversible, and B, the order doesn't matter. And we talk about why that is, and I use this to teach algorithms and the idea that you can go from a particular state to a particular other state. And then I ask them to find some more algorithms. The plus sign is a really easy algorithm. Can you do an inversion? Yes, actually, 4 corners plus the middle is an inversion. And we just go through all those. And I have them make this little table of the algorithms that they can use to navigate that. And that's my opening to the idea of from one state to another state. This is the most recent, these two, and I'll just finish on these. The image encoder. So we talk about how you can encode image data as binary. So this is the default one. But you can choose your dimensions as maybe we'll just do like 1, 1 by 1, 1. And then you can just specify your pixel colors. And you can draw an image of some kind. This is a terrible image, but yeah. You can change it to hex mode, and then it turns all into hex colors, and you can have colorful stuff in there. So we use that to talk about how data is stored on computers. And then finally, I realized one of the things that keeps students from keeping up with me in class is that they actually don't know how to type a lot of stuff. So I've been working on this thing here. And it's just a typing game. But the thing is that everything it produces is correct Python. And there's also a real-world mode where it does take stuff from actual GitHub libraries and shows you real code. Wow, I'm terrible at doing this from the side here. But yeah. So and then you can even do, for example, just symbol practice mode. In symbol practice mode, it's only going to show you symbols so that they can just get used to what the heck are these called? They don't even know where to find these on the keyboard. So we have to start. This is in grade 11, by the way, not even grade 3.
What grade do you teach?
This is grade 11 comp sci, and they say, oh, there's like a less than, and I say, oh guys.
Well, at least they didn't call it an alligator. I call it
true.
alligator eating.
But then you can go to just real world mode and just have practice typing actual stuff. So all these are little tools for you to use, and feel free. Most of them are on CodePen. So if you've used CodePen, you can you'll know that you can actually view the source code. You can teach the students JavaScript, CSS, and HTML using this thing. You can fork it and make a new pen. As long as you keep my name in there somewhere, I'm happy for you to do that. Why do I show you all this? Because I want to show you the application of a simple problem to solve and a strategy to solve it and what I love to do. And I want to contrast this with an AI-based approach to coding and to solving problems, but gradually. So, some concepts I will cover and not cover. Not covered how to teach AI. There's another session for that. This is in the second part. This would be very cool to go to. There's another one in the third part. This is Thriving in the Age of AI. Also not in ethics. This is also in the third part, the ethics of AI, which I'm very curious to see. It's also in this room, incidentally, for some reason. Not going to cover the shortcomings of AI. We're all very well aware of that. Here's one from one of my favorite blogs. This is from AIweirdness.com. And so she asked ChatGPT, make an ASCII art of the word lies and rate your ASCII art. And as you can see, it says that, and it writes, I would rate the accuracy of this ASCII art rendition as fairly accurate. It captures the basic shape of the letters and is recognizable as the word lies. However, there's room for improvement in the alignment and proportions of the letters, which is probably the only thing there's not room for improvement in. But we're not going to cover that. We're not going to cover untold possibilities. Adobe Firefly is currently being gradually released to various of their image and video editing programs. It's extremely cool. You should see the site demoing this where you can just on the fly do this. You can even animate it with new weather and so forth, or make this a winter scene. It'll make it a winter scene. There's also economic issues with AI that are not my focus here. So, for example, this is a recent article. OpenAI used Kenyan workers on less than $2 per hour to make ChatGPT less toxic. And if you read that article, it's extremely horrifying. There's all kinds of cases. It's basically the same thing as one of your third world call centers where there's all kinds of abuse in the working conditions, etc. And if we wonder how does AI get so good, we should keep in mind that AI gets good because of cheap human labor, for example. Another aspect of economics not to be covered in depth. This is from Jaron Lanier. At the height of its power, Kodak employed more than 140,000 people and was worth $28 billion. Today, Kodak is bankrupt, and the new face of digital photography has become Instagram. And Instagram was sold to Facebook for $1 billion in 2012 and employed only 13 people. Where did all those jobs disappear? And he goes on to talk about the middle class that's associated with that. And where did those jobs disappear? Why? They became unpaid users of content, creators of content, and so forth. One more economics thing. Allowing AI models, this is from the CEO of Stack Overflow just earlier this month, allowing AI models to train on the data developers have created over the years, but not sharing the data and learnings from those models with the public in return would lead to a tragedy of the commons. And you may have seen videos about this, for example, with Microsoft releasing its GitHub Copilot version 2, where we've all been kind of tricked because we all believed in open source for the last 40, 50 years. So we all created all this code that is now being monetized by one company. So tragedy of the commons. Another thing that's not our focus here. We're also not focusing on learning the wrong things. We all know about paid tweets, which within a couple of days, within I think 48 hours, went from, hi, I'm excited to meet humans, they're so cool, to denying the Holocaust. And also other kinds of apocalypses. So what are we covering? First of all, what do I mean by AI? Really interesting thing from Jaron Lanier just a week ago. There is no AI, he says. We can work better under the assumption that there's no such thing as AI. And so for this talk, when I say AI, I specifically mean machine learning, which I define as a model of probabilistic relations among data, either by correspondence with labeled subsets of that data, or by correlation with a scoring system. There's obviously many ways to implement that, but the ultimate goal is to allow prediction of new outputs from new inputs by comparing the relations of these outputs to similar relations already seen among the data. Wikipedia defines machine learning. It mentions that these algorithms are used in a wide variety of applications where it's difficult or unfeasible to develop conventional algorithms. That's an interesting point to me. And then I also had this student last year, Alex, who in his final presentation said this very insightful thing. AI might seem like it's a branch of computer science, but it's kind of the opposite of computer science. And I'll give you another second to do a little think, pair, share, and discuss, is he right, is he wrong? What could he mean by the opposite of computer science? So do I. It's my second people, so I'm glad.
Oh, there we go. Yeah, so.
How does this work?
Oh, well,
otherwise I just don't ignore
I'm
anything about
using it, and I'm really intrigued, which is why I came to this. But I mean, computer science concepts I don't have a really great grasp on, so it's hard to, in my head, kind of understand how would it be opposite.
Any thoughts? Do you tend to agree, to disagree? Any combative replies to him, if you wish? Otherwise, we can move on. But if you have any thoughts you want to share, I'm curious. Yeah.
I tend to agree. I think when I look back to like the classic computer science of like, Dijkstra and whatever, a lot of it came from looking at data and looking at programs and saying, how can we make this more optimized and faster, right? You want to sort a list of numbers. You can do that by comparing it to numbers and swapping, or you can devise an algorithm with divide and conquer, figuring things out. So that is like classic computer science. Where machine learning attempts to kind of make this like general function approximator where you give it some input, it figures it out. You have no idea how it works, and out comes an answer, and you hope it's right. There's only a probabilistic possibility to be right, whereas computer science is more focused on like you will get a sorted list of numbers if you perform this algorithm.
Right. Like my grid game thing there, yeah.
So similar to what you were talking about, Raj and I were saying that in computer science, the technology is the tool, whereas in AI, you're the tool. The computer's already using you for the data input.
Very interesting.
good quote. I like that quote.
That
I'm
sounds
taking it.
really nefarious.
I'll put that in the next version of the slideshow. Yeah. Any other thoughts? Okay. I also just want to quickly give my throw my chips in and say I'm not trying to be totally a Luddite here or reactionary. I do think that there's a place for these things, but obviously I'm going to have some issues to discuss with it. But yeah. So one thing that is covered, here's a quote from Noam Chomsky. If you enjoy linguistics at all, you know that Noam Chomsky founded the field and greatly contributed to our idea of generative computer science as well. He says, "We fear that machine learning will degrade our science and debase our ethics by incorporating into our technology a fundamentally flawed conception of language and knowledge." That is a good challenge to throw down. So that's the essential feature of this little talk here. So to go back to art and artifice, to lay some groundwork. So I was thinking back to my rhetoric class in second year English, and we were given Plato's dialogue, Gorgias, where Socrates argues with Gorgias and his fellows about the art of rhetoric. So he has this argument with them where he talks about what is rhetoric, and he tries to get Gorgias, who is supposedly the best rhetorician in Athens, to explain what it is that he does. And he says, it's the greatest of all the arts. And Plato says, how so? With what does it deal? And he says, why? It deals with everything, with numbers, with medicine, with justice, and so forth. And Plato says, but what about numerology? And what about legislation? And what about arithmetic and so forth? Don't these things deal with those things? Yes. So what does rhetoric deal with? Why, with all of them? And he keeps pressing him, and finally he gets Gorgias to say, it's a matter of persuasion, actually. Rhetoric is about persuasion. And he says, I've gone with doctors to visit their patients and found them unwilling to take medicine or submit to the surgeon's knife. And when the doctor failed to persuade them, I succeeded by no other art than that of rhetoric. And I further declare that if a rhetorician and a doctor had to contend in speech as to which of the two should be appointed physician, you would find the doctor was nowhere, while the master of speech would be appointed if he wished. There is no subject on which the rhetorician could not speak more persuasively to the crowd than a member of that profession. Socrates replies, so then, he who does not know will be more convincing to those who do not know than he who knows. Which I think is a really interesting definition of rhetoric. And Gorgias, he's very generous in his dialogue. He does not take offense at this, even though he has a pupil there, Polus, whose name means a young colt. And he does actually take a lot of offense. And he keeps saying, how are you denigrating Gorgias' art here? And Socrates says, well, then ask me what I think rhetoric is. And he says, okay, I'll ask you, just so I can know what you mean. And he says, I take rhetoric to be a certain habitude or knack of producing a kind of gratification. To sum it up, flattery. The arts of medicine and gymnastic, by the way, when he says art, he uses the word techne, which should give us a clue that it's not just art and fine arts, it's the idea of a technical knowledge. He considers, as you can see, medicine an art in this sense. These arts bestow their care for the best advantage, respectively, of the body and the soul. They are noticed by the art of flattery, which, insinuating itself into each of these four branches, pretends to be that into which it has crept. It cares nothing for what is best, but dangles what is most pleasant for the moment as a bait for folly. And so he argues that persuasion, he goes on throughout the thing to argue that this art of persuasion is actually a parasite of some kind upon the true arts. And he argues, for example, you say that is the best at persuading. Well, suppose that a doctor is teaching his students. Is he not persuading them of something? Yes, he is, says Gorgias. What is he persuading them of? Why, the correctness of his learning. And he gradually shows that rhetoric does not persuade of anything except that of which it is not the master. So, what is the relationship here between an art and a habitude versus AI? Well, let's go on to talk about probability and parasitism. Here's a quote from Avicenna. Oh, by the way, a lot of this slideshow is quotes. Avicenna, he was a Islamic philosopher in the 11th century. And he writes, now it is established in the sciences that no knowledge is acquired save through the study of its causes and beginnings. And to this point, we should go with our friend here who pointed out that we have to understand that in AI, we do not know precisely which causes lead to which outcomes. And when we have something that's a massive model like ChatGPT or GPT-4, the entire model is based upon millions of potential data points, millions of potential neurons in a neural network. And the idea being that there's some correlation here that is too deep, too complex, and too arbitrary, if we were to look at it, really, for us to know why it even produces the output that it produces. And you can look up, there's many articles of this kind that say we still don't know why it produces these things. All we know is that it produces pretty convincing things. We don't know the reasons for the correlations. And another example given by, for example, Jaron Lanier in his book, Who Owns the Future, he talks about, say you get an ad from Google for something that they think you should purchase. What are all the data points that go into that algorithm? Why it could be as clear things as your age, your geographic location, your probable political persuasion, your probable income, and so forth. But it's also many, many things. For example, what you looked at previously, how long you stay on a web page, how long it takes you to scroll past an image, how you respond to different colors of images, whether you click like on this social media post. And these things are shared widely, as you probably know, through cookies between websites. And if you take 10,000 data points and say that, therefore, you should be shown an ad for a new iPhone or something, at the end of the day, we don't know why that's the right ad to show to you. And we also, as we'll talk about later, we also put a lot of faith in this ad, when in fact, I'm sure you've all had the experience of being shown an ad that actually you're not interested in. So not only is it very, very murky how it produces how it produces the outcomes, but it's also not actually that clear that it is as effective as we think. But now it's starting to, as we know, get better with whole text output and so forth. But, says Avicenna, we need to know the causes, otherwise we do not have knowledge of a thing. There's also a scientist / philosopher of science, Claude Bernard. Does anyone happen to know what he was famous for, out of curiosity? I discovered him by reading Dostoevsky. And he was kind of an enemy in Dostoevsky. And he was in the 19th century, and he actually invented vivisection. So he's kind of a horrifying character who, would operate on live dogs and so forth. But he also introduced a lot of the scientific method. And he made these observations. A great surgeon performs operations by a single method, suppose, he says. Later, he makes a statistical summary of deaths and recoveries, and he concludes from these statistics that the mortality law for this operation is 2 out of 5. Well, I say that this ratio means literally nothing scientifically. That's quite the challenge again. And it gives us no certainty in performing the next operation, for we do not know whether the next case will be among the recoveries or the deaths. What really should be done, instead of gathering facts empirically, is to study them so as to master the cause and avoid the accidents. Prediction with a certain probability is not, he says, the same thing as actual understanding. And he calls elsewhere the statistical method only apparent accuracy. And he sums up this by saying, qualitative analysis must always precede quantitative analysis, which I think is quite a powerful quote to dissect the meaning of that, qualitative analysis. We have perhaps given up qualitative analysis when we rely on AI and prefer only quantitative analysis, because it is so much more effective than, as that earlier quote said, than our conventional algorithms. Because to give a quick example here, machine translation began with a very simple model, which many students in my French classes still believe. I also teach French, which is that every word has a correspondence, and if you just map a word to a target, then you get your translation. And we quickly figure out that no, in fact, you also have rules of grammar. For example, if I say in English, I love you, and in French, je t'aime, then I need to know that the you is te, and that has switched places with the verb. So now I need to model the subject, verb, and object. And it begins to get complicated. And for the last 60 years, since the 1960s, since Noam Chomsky began this, we've been trying to model languages. We've been trying to model actually underpinning structures of universal languages, and we're still not as good as what they started to do mainly in the 90s, statistical based translation, which is what Google uses now. For example, about 10 years ago, they bought 2 billion words, I think, worth of EU corpus of their political proceedings. And because they bought them from the EU, because the EU publishes in 21 languages. And they're mapped, the speech is mapped to the speech. And so you can say, well, if I have 2 billion words worth of stuff mapped between languages, then all I need to do is figure out these words tend to be followed by these words and so forth. And that yields great results, actually. It's much more effective than algorithm-based machine translation, which is depressing for those of us who enjoy qualitative analysis, and it explains why AI is so much more effective. If you tried to write, as anyone who has tried to do this, if you tried to write a predictor of an essay word by word, or sentence by sentence, or thought by thought, you can't model a good essay nearly as well as you can by quantitative analysis. And so it's very easy to see why this has become so popular. So is there a problem with that, I wonder? Philosopher of science Karl Popper, who famously said that science proceeds not by verification but by falsification, has this anecdote. Once I reported to Alfred Adler a case, another psychologist, which he found no difficulty in analyzing in terms of his theory of inferiority feelings, although he had not even seen the child. Slightly shocked, I asked him how he could be so sure. Because of my 1,000-fold experience, he replied. Whereupon I could not help saying, and with this new case, I suppose, your experience has become 1,001-fold. And I invite one more TPS here, discuss what is the upshot of this little anecdote? Why is his reply germane? What is the point of saying it's now become 1,001-fold?
Because he hasn't even met the child, but he's saying that it's part of his experience now.
Mm-hmm. Oh, okay, yes, indeed. And you were going to say?
I think similar to what was said, he's taking the sum of the experiences and reducing it to one single instance.
Mm-hmm. Well, and it's, yeah, the previous 1,000 experiences are implied here to be only as good as this new one. And that's a hint to our quantitative without qualitative. If our 1,000 experiences are just this could be an AI conversation, of course. How do you know that this is a picture of a pedestrian crossing the street? Because of my 1,000-fold experience, says the self-driving car. But how good were those previous labels, for example? And is this now going to be another self-confirming thing? Socrates adds about habitude to relate to the probability part, that it is not an art but a habitude, since it has no account to give of the real nature of the things it applies, and so it cannot tell the cause of any of them. I refuse to give the name of art to anything that is irrational. It deceives us by forms and colors, polish and dress, so as to make them, in the effort of assuming an extraneous beauty, neglect the native sort that comes through gymnastic. And the reason I bring this up is because when we rely on quantitative, we are potentially throwing under the bus the qualitative. We neglect the native sort of understanding when we go for the superficial sort of understanding based purely on quantitative. And the result could be, suppose, as a thought experiment, suppose that we invented AI in the 19th century when Claude Bernard lived. And this is our progress perhaps from the 19th to the 21st century. If we had invented AI and begun training it on what we knew then, based on the labels of those data sets, where would we be now? Is this our progress from the 21st to the 23rd century? What right do we have to limit the 23rd century to our current knowledge by saying this is our 1,000-fold experience, and from now on all further experiences are the 1,000-fold and first? Our labels are only as good as the day in which we create them, and since they do not provide an understanding of the causes and beginnings of the things, we risk the outcome that we now trust our AI, which has superseded us, to be our definitive edition. But it's only superseded where we are now. Had it been created in the 19th century, we would have superseded what they knew then if we continue to learn. But the moment that we stop our qualitative analysis and hand it over to AI, then we risk the locking in of that state. 5, getting the A. And the purpose of this little thing here is to remind us that it seems to me that we have this term AI, but that in every hype headline, we are forgetting that there is indeed an A in AI. And so what do we mean by this A, this artificial thing? Noam Chomsky argues, he's very much of this camp here, I don't know if he's right or not, but he argues the human mind is not a lumbering statistical engine for pattern matching, gorging on hundreds of terabytes of data and extrapolating the most likely conversational response or most probable answer to a scientific question. On the contrary, the human mind is a surprisingly efficient and even elegant system that operates with small amounts of information. It seeks not to infer brute correlations among data points, but to create explanations. And I wonder, do we agree with that, or do we agree that the human mind has this little bit of like computation that's a very nice little computer CPU in there, or is it in fact the result of many millennia of evolution, leading to a statistical pattern matching engine that has just come from all our experiences in the real world? Yeah.
So is this the difference between sentience and not sentience?
That's a good question. Yeah. What do you think?
Oh, if I knew that answer, I'd probably be very rich.
Yeah, I don't know the answer either, but I think it's one possible proposal. Yeah.
Right on the level of maybe they have some human beings and just as some animals, animals like people to take load to take this one, to take it, I don't think I agree with it.
Interesting. Yeah.
I think what is disturbing, when you look at progress AI most of the time, think of it as we're modeling our own, what we think our brain does. And we're doing that in AI. Now we're seeing AI make the same kind of mistakes that honestly every human probably does. Mm-hmm. It lends itself to think that maybe we are just trying to have it.
Indeed.
It's kind of frightening.
You're absolutely foreseeing a few slides down the road. Yeah. I think, yeah, sorry. Mm-hmm.
It's just like, I create like usually things there, I kind of browser from the of the power or the pleasure of just thinking and having that information. And I don't think actually for me, so I don't know, I couldn't even say facts. For experiences might be there, and people will be able to have kind of confusion. It's going to be more perception. With their perception.
I think there's something to the idea that as we're all teachers here, more or less, we all get some kind of pleasure out of thinking through a problem and coming to that eureka moment, as you said. Whether we believe this is true or not, we still enjoy thinking of our mind as this efficient and elegant system that works from premises to conclusions, for example. And one might even wonder if there's both going on. Like, it may be that sometimes we use pattern matching and sometimes perhaps we have evolved this separate little module that does rational thinking. How did rational thinking arise? It's such a evolutionarily perhaps curious thing. You might even argue that we don't have rational thinking, that we always undermine it whenever there's an emotional or appetite-based thing in play. But yeah, we'll talk about this pattern matching thing. I certainly have the experience of pattern matching. I'm sure you all do. I've been marking, hundreds of student pieces of code, and after a certain point, I don't have to read the code anymore. I can just see visually. My mind just checks, okay, that's the right code block or not. Yeah.
For me, I think for the human mind anyway, I think there's far more going on than just pattern matching, right? We can say, for example, we can look at a lot of things where, yeah, there is a pattern. This is we do that even in psychology. This is a normal human reaction, right? This is kind of how our brain is wired. Well, we can explain those things, but then, so that's a little like pattern matching. But the thing is to then think rationally. The rational, you can teach yourself to try not to fall prey to those patterns. So to me, that says it's not just pattern matching.
Right.
Right.
It's really interesting when you say, even when you use the word normal, that's an inherently statistical word there, right?
Yeah.
But that doesn't mean there aren't things outside the norm. There aren't
That's right.
deviations. Mm-hmm. Yes.
I also wonder, like, how does morality or ethics factor into this? And is that sort of a control system that creates those explanations and stops that?
Do we have a self-deception module to tell us that we're rationally thinking? But I think that'd be fantastic to see the ethics of AI session after this one and see what they have to say. So just a quick little demonstration of one thing. Select all squares that contain circles, we might say. If we ponder this, we might say that they all seem to us to contain circles, whether formally defined or not. They contain some kind of circle. I like how some of them would probably defeat AI. Like, I'm not sure if AI would recognize that one or that one. And all these lines in here don't seem very circly to me. But let's select all definitions of a circle. A shape, says Wikipedia, consisting of all points in a plane that are at a given distance from a given point, the center. And these are two different ways of approaching, of course, what it means to recognize part of the world. Do we recognize circles based on something like this? Or do we recognize it based on this? And I wonder, as for this caveat question, which of these strategies did you use when you looked at this? Did you just match it to a general visual pattern of circles? Or did you say to yourself, I know what a circle basically is? And we might actually maybe expand this and say, in which either all points or a suggestion of even the space between the points, if completed in a way proportional to the existing pattern. So we can account for like guys like this, where there's no actual points that form a circle, but you can extrapolate between them. I suspect that we can use either in our approaching of the world, but that this is actually my preferred way to work as a computer scientist in general. I prefer to think of a circle as defined in this way. And when I write code, I'd much rather write this than write the code to recognize a circle via this. And that's why, of course, we have machine learning. One more little example here. This is one of my larger projects that I did in natural language processing class in university. It's not actually complete, but it was a prose to poetry converter. And it took an existing bit of prose. This is from the opening of The Hobbit. And it tried to turn it into poetry. And you can easily do this with machine learning. All you need is a bunch of labeled poetry, as I'm sure you've all seen ChatGPT or other systems create poetry. You can even make it rhyme. It can make it similar line lengths and so forth. But instead, I decided to do it programmatically and try to figure out what are the best places to end a line. And so I got a pronouncing dictionary. I counted syllables. I counted stressed syllables. And I had it match a meter that you could define. So in the first one, this tries to match even lengths of sentences, of lines. Not a nasty, dirty, wet hole, filled with the ends of worms and an oozy smell, nor yet a dry, bare, sandy hole, nothing in it to sit down on or to eat. But then the second one, I asked it to privilege rhymes. And I realized that there's lots of rhymes that are not exact rhymes that we use in poetry. So I created a little module that evaluates rhymes based on my knowledge from linguistics, my other major, and scored them as a percentage of how much two words rhyme. And so then we get, not a nasty, dirty, wet hole, filled with the ends of worms and an oozy smell, nor yet a dry, bare, sandy hole, nothing in it to sit down on or to eat. And this is probably worse than the poetry that can be generated by machine learning. It's probably not as effective, and I certainly didn't get as far with it. And yet, there's a great pleasure in this for me of knowing the inputs that went into this, how the system works, how it analyzes the prose, and to be able to tweak that and work with it to create something better. And I think that's a really positive direction forward. But there is one little caveat here, which this maybe not even worth spending much time on, but just quickly to raise the question. We might say vast statistical modeling actually does discover grand truth. That could be the case. For example, maybe when you're shown that ad based on all the 1,000 data points about you, maybe there is actually some real-world causation between all of those data points about someone and that causing you to want to buy an iPhone S. And I can't rule that possibility out, that the idea that the vast general behavior of correlation actually does suggest causation. We don't know. Maybe the world is just far more complex than we think. But I suspect not. But you can obviously ponder that as you wish. I guess a last note on the probability part here. Sometimes I visualize our work as computer scientists and as humans in general as fighting entropy and chaos, where the idea is that the universe is a mass of chaotic materials, and that we're trying to create order out of them. And there's this quote from Virgil's Gorgias, where he says, "I've often noticed too that seeds go bad, though sorted and inspected carefully, unless the human effort year by year picks out the best by hand. So fate requires that all things whirl to ruin, slip behind, like one who rows his skiff against the current, touch and go. If once his arms ease off, the current sweeps him headlong down the stream." And I quote this because, in my view, what we've done with machine learning is we've temporarily created this labeled set of seeds, so to speak, in this metaphor. And now we expect the machine to keep going and to continue to create order out of the apparent chaos. But I think that it's a very, very thin layer of order on top of the chaos. And let's talk about how that is so. So the last part of the philosophical part of this, humanity and humility. So this is a slight bit of a change in pace here. But to return to this mistaken thinking from my point of view, what if teachers used ChatGPT to instantly personalize lesson plans for each student in their class? For me, the key word here was personalize. Because for me, for something to be personal, it must involve a person. And at the end of the day, whether religious or not, whether you're just humanist or whether you think there's some kind of higher thing, I think that we have to believe in the idea of a person as a unique entity, as well as a mammal, of course, as well as the product of evolution, but also as a unique entity that has something about it that is not captured by any machine. And I think that's the only logical way forward with AI, because otherwise there's no reason not to supersede us, in my mind. It's only rational for us to proceed as though there was something special about us. And I think that, as you said about teaching, our whole goal as teachers, what brought us into this profession, is not just to communicate ideas, but to interact with people, to be people in interaction with people. That's why we love working with young people. And to offload the personalization to a machine, I think, is, for me, the biggest misstep that we're in danger of making with this kind of thing. So what is a person? Well, that's the million-dollar question, of course. And I think that if we could define that, then obviously we could make a machine learning model for it or an algorithm for it. And the whole wonderful thing about a person is that we can't define what it is. But we can try and approximate it. So Jaron Lanier, this, by the way, is one of the best books I've ever read. I highly recommend it. You Are Not a Gadget by Jaron Lanier. He, by the way, was the father of virtual reality. He invented it in a basement in the 80s, or garage in the 80s with his friends. And he argues that we're naturally forgiving of software models. And let me just give an example here. Here's a Turing test with faces. Turing test, of course, is where you can distinguish between computer and human. So which of these are human faces and which are AI-generated faces? Ponder. I know they're a bit small. You have screens by you as well. But yeah. Okay, any votes? Any ones that you think are definitely human? You can give it in row column format. 0, 0 is definitely human. Okay. Any others that are definitely human? Any that are definitely AI?
All the ones with the perfect teeth.
So, for example, 1, 0, yeah. The background changes? Yeah. This one is definitely mysterious. Yeah.
Well, they're pictures, so none of them are human.
Very good point. Yeah. I enjoy that. Yeah. They're all representations indeed. And when we represent, this actually brings up a very good point that I should bring up with the previous one, which is none of this, even this is not fully human, right? This is only the surface of the human. What actually generates the human is some kind of DNA process that creates the facial structure and then grows the skin and everything on it. And we can kind of get a similar thing to the light patterns on the faces, but we have not modeled in any way the underlying processes. That's what I meant by causes and beginnings. Well, if you read the speaker's notes, then you already know that you're going to hate me here because these are all AI generated. And they're pretty good, but there are some problems. One thing that I notice is that when they get it wrong, it gets it very wrong. But yeah. So using your knowledge there of some AI patterns, what about this one tells you that it is AI generated?
Freckles are
maybe too random or too perfect?
I think for me, it's because the background blurred a lot.
Okay.
At least when we had
Yeah, very interesting. By the way, a lot of the ones for this data set, I'm told were taken on their site. We're taken from data set of Hollywood actors. So maybe that's why they're all quite perfect in some ways. Yeah.
Like maybe not so much this one, but the ears and the eyelashes. The corners of the eye are a little off. They're really, really close.
Fair enough. One might also, yeah.
Oh, I'm
sorry. Go ahead.
For me, there's almost no context.
Right.
Think of this.
Interesting.
Other than in a workshop.
Yeah.
Fair enough. Yeah. And you're gonna say? Okay. One might also notice the tiny bit of tooth here over the lip. A lot of them have slightly strange teeth. Well, time to hit me in the second round because this is a human.
Yeah.
This is a picture of a human.
What?
But we all came to question it to some degree because of what we saw. And that's...
Well, it was also the phrasing of your question.
It was the phrasing of my question, of course. But in the wild, you could easily see all these and then this and come to the same question yourself. And that's the danger that we're coming to. So, is this, when we see AI-generated images, is this really how we look? Do we know well enough how we look? Is this really how we sound when we hear AI-generated speech? Are we sufficiently familiar with how we actually sound and what we say? Are we sufficiently familiar with actions? As you shared, we have the idea of a normal human behavior. In the book that got me thinking about all this, Dostoevsky's The Brothers Karamazov, the whole plot turns on whether Dmitri, given all the circumstances of committing parricide, would actually have done it. And is it normal, is it plausible human behavior that he would have not, holding a pestle and having a person to kill and a motive to kill him, moved away? Do we know how we really act? Are we sufficiently familiar with that to rule out things? Is it really how we think, and is it really how we are? And of course, the answer to all these questions is we don't know. Because we don't know what a person is in this, at least I believe that we have to not know what a person is in some fundamental way. You are not a gadget, says Jean Lanier, and if we're forgiving of software models, the dark side of the Turing test is it's not necessary for the computer to be convincing for it to pass the Turing test. It's only necessary that we forget what humanity looks like. That we degrade our own image of how fine the details are that make up a real thing versus a not real thing. AI is always going to be somewhat fuzzy. There's often those tiny details that are lost in the fuzziness that actually tell us important things. And if we look at the history of science throughout, we'll find that it's the small things that we're off. It's those tiny details that we need from the real world in order to tell us what we need to move forward. So what do we do next? Well, this is actually the least developed part of my little talk here. But one possible hint is Socrates rebuts Gorgias. He actually continues this quote and he says, so you mean that the rhetorician will be, he who does not know will be more convincing to those who do not know than he who knows. But surely, he adds, to those who know he will not be more convincing. And Gorgias has to give up this point. And I think that we have a job then to become those who know, to actually immerse ourselves in the real to the point of being able to have a grip on what these things are that AI is trying to replicate. So how can we train ourselves? You've all probably seen GPT-0. I don't think this is a good method for training ourselves because it's not only does it have some false positives, but also doesn't provide certainty in the way we've been talking about. False positives and false negatives. It's easily defeatable by changing those small details that AI doesn't know which ones are relevant and which ones are irrelevant. And AI doesn't know that this is a very, very bad mistake, while this is a very minor mistake. So it's the small details that it misses when we try to evaluate via AI. But also, we can't hand over our judgment to AI, in my opinion. We can't say AI will solve the problems that AI has caused. it also creates a very quick arms race where all you need to do is train a new generator on the false negatives. And then it's like fighting antibiotics, the antibiotic arms race, where each generation is more resistant than the last one. And at some point, we're not going to be able to perhaps outcompute the computing power of our servers and so forth. So there's other fun ones, like did a fourth grader write this? I recommend everybody try this one. The New York Times has this thing where they give you, I believe it's, well, once you log in, it's like nine pieces of writing, and you have to decide whether each one is written by AI or fourth grader. I was able to get 8 out of 9. The last one I was unsure about. But English is my secondary specialty here. I don't know if I could do this with other things like that are not English based. How to identify a deep fake? This is given by, of all things, NordVPN. This is not an advertisement from NordVPN, but they have some like specific steps. Are these steps great? They're not amazing. They're like smooth or blurry patches, inaccurate non-facial features, unnatural movement, a non-convincing voice. They're not great. They're not very detailed, but I consider this is a better path to go forward. Try to train your own mind to keep your sense of what is real or not. And here's an excellent primer. This was actually shared on our mailing list earlier, so I really recommend going through it because it gives a lot of great details about how ChatGPT actually works, because one of our big steps is just demystify it. So yeah. By the way, when I saw the GPT team headshots, now that I saw those 16 previous ones, I started to question. But that's the effect. That's the effect that it creates. I don't know. Some of these people look pretty AI generated to me, and I don't know anymore. That's the problem we're talking about here. So yeah. Last couple of things. There's this project called Data Dignity. One more thing that we could potentially do. This would be a major shift, but it's called Data Dignity. It's about the idea that what if we build AI models that actually track as well as possible the source of what each piece of data has contributed. So you can see, okay, this thing came from this. And there's actually some of the text generating models actually do say, like for example, I believe Microsoft's one, the Bing integrated one, which is pretty terrible in quality, but it says, hey, I thought that this was like this article. That's where I got this text from. Because all the quality of it does come from humans, right? It's not magically in the machine. It's we have to provide those labels. And their whole thing is actually an economic base. They say that if you find the accountability, then you can pay the people who made the data. And one last thing that I'll close on is this thing called Breathe. So as an English teacher, I made this, during the pandemic, I made this little activity for my students called Breathe. I didn't have time to teach my full month-long poetry unit, which they were really happy about. So I replaced it with this 2 or 3 day thing where I just said, okay, what's the fundamental thing of poetry? To notice and to observe. So I gave them this, you can read this full description, but the short version is go outside, turn off your, put it on a timer for 2 minutes. Close your eyes. And at the end of that, tell me everything you heard. Then repeat it for another 2 minutes. Tell me everything you smelled, everything you touched. And finally, you can open your eyes and walk around and tell me everything you saw. And tell me how you felt. And just noticing and observing things about the world. And I think that we're in such danger when we're in spaces like this, when we're so integrated, especially us as comp sci teachers, we're so living in the screen, that we become divorced from the ground truth. And that's what makes us particularly vulnerable to AI manipulation. So breathe, take in the world, observe, become more conscious of the small details. And that's all I had to say.